Alright, as we continue multiplying polynomials, now we're going to look at multiplying a polynomial that may involve either a higher degree or more terms than a typical binomial or monomial. So if we look at these examples that go along with the notes that were attached, the first example includes a monomial times a polynomial. It doesn't matter how many terms we may have in that polynomial, but ultimately it's just, you take the monomial and what you're going to do is you're going to distribute. So we're going to take this monomial of 2x to the third power and we are going to distribute to each term of the trinomial. Okay, so when we do that, 2 times 4 is going to give you 8. X to the third times x squared, you add the exponents to give you 5. 2 times negative 3 is negative 6. X to the third with x to the first, again you add the exponents to give you 4. And the last one, 2 times 5 is 10. And you have x to the third power. So the final product is 8x to the fifth minus 6x to the fourth plus 10x to the third. Okay, so again, just repeat the distributive property. Okay, so that was a monomial times a trinomial. When we take that monomial times a polynomial that has more terms, so in this case we have 4 things that we are multiplying as our distributive property. Again, follow your exponents, follow your distributive property. Negative 6 times 4 is a negative 24. X to the second goes with x to the fourth. You add to get 6. And then the y to the third goes along for the ride because there are no other y's. Negative 6 times a negative 5 is a positive 30. X to the second, x to the third adds to be 5. And we have y to the 4. 3 plus 1. Then you have negative 6 times positive 6, which is going to give you negative 36, x to the fourth, and y goes to the fifth. Then you have negative 6 times negative 8, which is a positive 48. We have x to the third and y to the sixth. And this becomes our final product. So our final product, again, has 4 terms, and we just follow those distributive properties. Alright, the third example involves a binomial times a polynomial, in this case a trinomial. So now what we're going to have is we're going to have the distributive property, but you're going to take this first term and you're going to distribute that one to each part. So in that case we have 4 times 5 is a 20 x to the third power. Then you have 4 times negative 2, which is a negative 8 x to the second power. 4 times 1 is 4x. We then have to multiply this negative 3 and distribute that one on through to each term in the second polynomial. So we have negative 15 x to the second, we have a positive 6x, and a negative 3. So now what we're going to look to do is combine like terms. And so we have a square and a square, we have an x and an x. So we'll combine those, but in the end the 20x to the third remains 20x to the third. Negative 8 and negative 15 is going to make negative 23 x to the second when you combine them. This 4x and the 6x combine to make 10x, and the minus 3 just goes along in the end because there are no other constants. So the final product is 20x to the third minus 23x to the second, 10x, and a minus 3. In the next example, we have two trinomials that are being multiplied together. So when we have two trinomials multiplied together, it again becomes the same repeated distributive property. You just happen to have three things that need to multiply to three things, so there winds up being 9 total products in the end. So we're going to take this 5x and distribute it through to each part. So that's going to be 5x to the third, a minus 15x, this is to the fourth, 15x to the third. 5 times 4 gives you 20x to the second. We then multiply the 2 on through. So 2x times x squared gives you 2x to the third. 2x times negative 3 is negative 6x to the second. Negative 3 times 4 is negative 12. Oh, I'm sorry. Got ahead of myself. 2 times 4 is 8x. So then we have one last one that we have to multiply in here. So we have negative 3 times x to the second. So the last one is this negative 3 times x squared, negative 3x squared. Then you have negative 3 times negative 3, which is a positive 9x. And the last two is a minus 12. Better 12 in there. Alright, so we now have 9 items of which we need to be able to combine like terms. So in the end, there is a 5x to the 4. That does not change because that has the only x to the 4. The only one that's a constant is the minus 12, so we'll put that down here. And then now what we can do is we can kind of look at x to the third, x to the third. So negative 15 and a positive 2 is a negative 13 x to the thirds. So those are gone. Then we have 20x squared minus 6x squared gives you 14x squared. Minus 3x squared is going to give you a positive 11x squared. So now all the squareds are gone. So then what's left is these 8x and 9x, which add to give you 17x. So in the final product, we have 5 terms, 5x to the 4, negative 13x to the third, 11x to the second, 17x, and a minus 12. So long process, but it's just, again, the repeated distributive property. As we move into these special cases, so the first special case that we're going to look at is if you have a polynomial raised to the second power. Okay? Now, the first thought process might just be that this becomes x to the second plus 3 to the second and saying x squared plus 9, which is 2/3 correct. What you need to do is you need to write this as x plus 3 times x plus 3. So now we use FOIL, or the repeated distributive property, and we're going to say x multiplies to both. We're going to say the 3 multiplies to both. So in the end, what we get here is x times x is x squared. The x times the 3 is 3x. On the inside, the 3 times the x is also 3x. And then 3 times 3 is 9. So, special case, because of the square. So notice we would be missing the 6x. So when I said it was 2/3 correct, if you just square the x and square the 3, you miss out on the 3x in the middle. Okay, so got to make sure that you write it twice when you have these special cases, and don't just square both terms. Okay, So another example of that here with our next polynomial. So again, don't just square both. What you're going to do is you're going to write this as 2x minus 3y times 2x minus 3y. And then what we're going to do is we're going to take 2x times each value. So we get a 4x to the second minus 6xy. And then when we do the inside and the last, that becomes a minus 6xy and a positive 9y to the second. So now we combine like terms in the middle, so you have a 4x squared, a minus 12xy, negative 6 and negative 6, and a 9y to the second. So again, don't just square. If we would have done 2x squared and 3y squared, we would have had the 4x to the second, right? And we would have had the 9y to the second, right? But we would have missed out here on the middle value of the 12. So you cannot just square those two values. You have to write it second. Use the definition of what that little exponent means and square it. Same thing's going to happen when you have it to the third power. It just becomes a longer process. So you're going to say x plus 2 times x plus 2 times x plus 2. That's what it means to have something raised to the third power. So now what you have to do is do two of these at a time. So we're going to do these two at a time. So use FOIL. First is x squared, outside is 2x, inside is 2x, last is 4. And you still have this other x plus 2, so this just comes down. So now we continue to simplify, and this is x to the second plus 4x plus 4. When you put the two x's together, still you bring down your 2x, or I'm sorry, your x plus 2. And then now we get into that scenario of having a binomial times a trinomial. Okay, so you would take this x to the second times each term. So in that case we have x to the third and a 2x squared. Then we're going to take the 4x times each term. So we have a 4x to the second and an 8x. And then we'll take this last term and we'll multiply that in. So we have a 4x and we have an 8. So when we combine terms at the very end, there's an x to the third. Now that's gone. We have two of them that are x to the second, so when I add I get x to the 6. I'm sorry, 6x to the second. And then we have our x to the first powers, which is 12 of them when we put 8 and 4 together. And then you have this plus 8 at the end. And so again, however it works, take your time, make sure you don't lose an exponent, make sure you combine using your exponent properties. But that's how you deal with the special cases. So now the last part of the notes involve just a couple of different ways to think about the multiplying with these values. So if we want to use the box method, that sometimes becomes something that students like to keep problems organized. So if I make a box, right, we can make this kind of extend. All right, what you're going to do is you're going to take your binomial, and we're going to place those right here. So 2x plus 5. Then we'll take this trinomial and we'll place those here at the top. So we're going to have a 4x to the second, a minus 6x, and a plus 3. And then it becomes kind of multiplying within a Punnett square. So we're going to take the 2 times the 4, and that's going to give us 8x to the third. The 2x is going to multiply to the negative 6 to give you negative 12x to the second. This 2x is going to multiply to 3 to give you 6x. Then we'll continue. 5 multiplies to 4, and that is 20x to the second. 5 times negative 6 is negative 30x. 5 times 3 is 15. But it's positive. Okay, so now what we can do is we can kind of look at these diagonals. So these two right here are a diagonal. These two here are a diagonal. And notice how the diagonals have the same degree. So knowing that, the 8x to the third has nothing that it can go with. 20 and the negative 12x to the second simplify to be an 8x to the second. The negative 30x and the 6x become a negative 24x, and the 15 just goes along for the ride with the 15. So again, that's using the box method. You can take any polynomial, even if it was a 3-term polynomial, a trinomial times a trinomial. You could just make a 9-square box. If you had something that had 4 terms, you could extend this box out here another row or column, however you need. If you had 5-term polynomial times a 5-term polynomial, that's fine. You would just have 25 boxes. This happens to be a 2 times a 3-term polynomials, so you need 2 times 3, you need 6 boxes. Okay, so, and then again, you add the diagonals if they're the same degree. Okay, so that's the box method of multiplying. The vertical method would just be multiplying things as though they were a 3-digit number times a 3-digit number. So 3x squared times 4x minus 5, x squared minus 8x plus 6. You line them up vertically. We are using the multiplication operation. And then you're just going to take 6 times each column. Yeah, let's not do that. So we're going to take 6 times the 5, 6 times the 4, 6 times the 3. Okay, so we're going to do that, and we'll get negative 30. Then we'll get 24x. Then we'll get 18x to the second. And those are all positive there. And then we take the (8x), but it's a negative 8x. Right, so you got to treat this whole thing here. And we're going to multiply that to each value in the row above. So negative 8x times negative 5 is a positive 40x. So we're going to write that underneath the 24x. Negative 8 times 4 is negative 32x to the second power. So we're going to place that underneath the other x to the second power. And then you have a negative 8x times 3x to the second. That's going to give you a negative 24x to the third power. So the last part here now, as we move on, we now have this x squared that we have to multiply to each of the terms above it. So x squared times negative 5, well, that's going to go as negative 5x squared, but we put it underneath the other x squareds. X squared times 4 is 4x to the third, and x squared times 3x squared is 3x to the fourth power. And now to solve and get our final result, we just add down each column. So negative 30 comes down, 64x comes down. This will combine 18, negative 32. That's going to combine to make negative 19x to the second. That 64 was positive. Negative 24 and a positive 4 combines to make negative 20, x to the third, and 3x to the fourth. Okay, so again, you can use the repeated distributive property, where you would take this value here, and then this value, and then this value, then take the 4x times each value like we did on one of the prior examples. Okay. We could also make a 9 square box and multiply it through and then add all the diagonals. But this is just another way of keeping a problem organized in a vertical format to get our final product there at the end. Okay. And the last way is to kind of combine both the first method that I showed you with the distributive property along with that vertical format. Okay, so this is actually a preference of mine as I multiply. All right, so as I multiply, I'm going to take this times each value in the second trinomial. So we wind up with 3x to the fourth. 3 times negative 8 is negative 24, x to the third. 3 times 6 is 18, x to the second. So now we're going to take the 4x, and we're going to distribute that into this second trinomial. So 4x times x squared is 4x to the third. So what I'm going to do is I'm going to line this up vertically right underneath the other x to the third. 4 times negative 8 gives you negative 32, x to the second. And 4 times 6 gives you 24x. So then the last one, I'm going to take this negative 5 and I'm going to distribute that in to each value in this second trinomial. So negative 5 times x squared is negative 5x squared, and again, I'm going to vertically line it up in the column of the x squared. Then I have a 40x, and I have negative 30. So now, in the end, we just add down the columns. Negative 30, 64x, negative 19x squared, and negative 20x to the third, and then bring down 3x to the fourth. So same example as the previous problem, just a different way of multiplying it. Right? Kind of a little bit less involved. It, again, kind of creates that same distributive pattern that we did at the beginning with kind of what we're looking to do. It's just then after you do that distributive property, you line them up kind of in a vertical format to add down. That way you don't lose the different exponents when you combine them at the end. Okay, so again, this will kind of conclude our multiplying polynomials and our polynomial operations for now. We did addition, we did subtraction, and now we're kind of on the second process of multiplication. And eventually we'll look into some dividing. That gets into something kind of called factoring, and there's also a long way of dividing them. So we will touch upon that, especially the factoring aspect of things. But ultimately, adding, subtracting, and multiplying are the beginning parts here of our initial work with polynomials.